Okay, so now let's go to our folder structure. Let's create a new group. And let's call this Chinese support or supporting functions. And let's create a new file. And this will be a Swift file. And I'm going to call this Chinese. So we want to implement some logic. Okay, we'd like to input an integer and get a pair of strings. One string using actual Chinese letters and another string using pinyin. That's exactly what we want. So I'm going to define a class, Chinese, and I want to define a static function, num99 to Chinese, num_int, which will return a pair of strings. However, it might return nil. Now the first string, let's give it a name so it will represent Chinese. And the second string will represent pinyin. And for now, just to pacify the compiler, let's return nil. Okay. Now, I'm not going to implement this yet. I'm going to ask myself, what result do I expect? So I'm going to create a unit test. So this is more in the direction of test-driven development, where we create the test before we actually implement the function. Okay, great. So let's actually create a new file, and I'll enter unit test case class. So next, and let's call this Chinese tests. So create. Okay, and I'm gonna erase this part over here. And instead of test example, test Chinese. And it's very important that it begins with TEST lowercase. Okay, we have this little rectangle here. If I change one letter, even capitalize this, then it's gone. And let's run the test. Now it's going to pass the test because there's no code here. So it's running our app, and now the test succeeded. Okay, but it's good just to test that it doesn't hang up, because earlier we saw that there's an issue that sometimes the tests hang up. So it's good to do that. And now I'd like to set up some data and then describe some expected values. This should be pairs of values or a nil, because our function returns pairs of strings or a nil. And then we'd like to just run test. Okay, so that's the plan. And now for the setup data, I'm going to consider a bunch of numbers. So let nums equal to 0, 3, 10, 13, 17, 20, 28, 39, 51, and 99. Now these are numbers that I planned beforehand. It's not like I'm just randomly making this up as I go. And now for the expected values, I won't really be able to type this. I did prepare this beforehand because it uses Chinese symbols, and this was actually quite involved to create. This was actually quite a lot of work. So I usually don't like just copying and pasting, but I'll do it in this case. So the expected values for 0, 3, etc. For instance, the number 0 is called something like ling, right? Ling, like going up, ling. So this is the symbol for ling in Chinese, and this is the actual string. Or say 13. 13 should be shi, like 10, followed by san, like 3. Okay, great. And we haven't used it yet, but we will use it. And I also want nil. Let's add something called nil nums, which will be a bunch of integers. Say 100, -10, 101, 102, -1, -2. And I actually prefer putting this in the setup. And the expected value is just nil. So this is kind of out of range, so I expect to get a nil from our extension. And now let's create the tests. And then we'll have to create a function so that the tests will pass. So for I in 0 to nums.count, let value 1 equal to, okay, now this won't work. I want to enter Chinese, but there's no autocomplete. It doesn't recognize the class. And that's because we have to import it. So we have to go back up here and add some import. So at testable, import, choosing. Okay. So now at least it recognizes Chinese. So that num to Chinese. And let's enter nums at the ith position. And let value 2 equal to expected values at the ith position. Now, value 1 and value 2 could technically be nil. So let's rule that out. So if let value 1 and value 2, if they're non-nil, then xcode test assert equal. And let's take value 1 dot Chinese and value 2 dot Chinese. And we have a little issue here. Yes, so what we could do is actually add Chinese over here. We also could have created a struct instead of working with pairs. That was definitely a possibility. And opinion. Yeah, it might have been cleaner to just create a custom struct. Oh, and I misspelled Chinese. It's embarrassing. Okay, good. Now we're good. Or I could have not used Chinese or opinion at all and just done value dot 0 and value 2 dot 0. But I thought it would be nicer if it's more descriptive. And clearly, maybe it would have been better if we would have created this with a struct. Okay, so opinion and opinion. So this is testing the values that we don't expect to get a null. And now let's test the nil case. So for num in nil nums, xct assert nil. So we're just checking if Chinese dot num 99 to Chinese is nil or not. Okay. Now let's run the test, and it's clearly going to fail. It's actually going to pass the nil test, right? If we comment this part out, let's comment this out. It's going to pass the test because currently our function only returns nil. Okay, so let's uncomment this. And now let's think what's going to happen, right? We're probably going to fail the test. So let's see. So we're running the test. This is very exciting. and the build succeeded, and the test succeeded. So what's going on? Clearly our function's incorrect, but it's passing the test. So let's see. So value 2 are all of these values, okay? Value 1 is nil, right? And then it fails this part over here. And then to this code right here, the test is actually skipped. So what we need to do is also test if value 1 is nil or not. So xct assert not nil value 1. Right? Value 1 should not be nil for these valid numbers, right? These expected values are valid. These expected values are all valid numbers. They're not optionals. And now it should fail. Okay? Because otherwise our test is just simply incorrect. And now it failed for all 10 values of our expected values list. And that's what was expected. Okay, so now it's time to start implementing. We will take a break in a moment, but I just do want to make things easier. Okay, so there's many ways to implement this function, and I recommend that you do try to implement it. It's an excellent exercise. Try to implement this function so that it will pass the previous test. Okay? And I'm going to add some code here that we'll use in the next lecture. So this was my implementation, and I'm very confident that there's a better implementation. So I created this array of pairs, Chinese digits with opinion, and notice this is starting from 0 all the way up to 10. Okay, so this is 0, this is 1, 2, etc., all the way up to 10. And I created yet another array that is almost identical. So this should bother us a little bit, but I found it convenient. So Chinese digits with pinyin, empty 0. So the 0 part, I just replaced it with empty strings. Now sometimes we have a trade-off between memory and speed or efficiency. So I wasted a little bit memory just so things would be a little bit more convenient for myself. It does seem that we could do better. Okay? You'll see my implementation in the next video. And I recommend you try to implement your own test. So that would be really great. That would be really great. And one more comment. You see, this code over here would be better if it was an enum. We could create a pinyin enum, and then we wouldn't have to recreate this at every point of the app, right? Because I'm copying and pasting quite a bit. So that would be also an excellent idea. And then you could temporarily implement this, right? Instead of using Chinese, you could use English or any other language you choose. Okay? Great. So what I'd like you to do, implement this function, right? num99 to Chinese. Okay? It's an excellent exercise, and you know, every one of us will probably create a different implementation. I think there's a better way than using what I'm doing. And you can kind of imitate play sound. And the point that should guide you is really just passing the test. Really passing the test. That's our goal. So great, let's take a quick break. Try to implement this function on your own. And yeah, have an amazing day, and see you next time.